Hello friends, welcome to the tutorial on getting started with IPython. What is IPython? IPython is an enhanced interactive Python interpreter. It provides features like tab completion and easier access to help. Let us first see how to start the IPython interpreter. First open the terminal by pressing Ctrl-Alt-T keys simultaneously on the keyboard. Type IPython3 at the prompt and press enter. If IPython is not installed, please refer to the instruction sheet. If IPython is installed, the IPython interpreter is loaded by running the IPython command in the terminal. The versions of Python and IPython that are installed are shown on the terminal. Some additional helpful information is printed by IPython. After this, we get a prompt with in bracket 1. Now let us see how we can quit the IPython interpreter. Press Ctrl-D keys. A prompt will appear to confirm if we really want to exit. Type Y for yes and quit IPython. Note that Y is given in square brackets, so it is default. We could also press enter and it will exit. Else type N for no if you don't want to quit IPython. Let us type Y. We have quit IPython interpreter and are back at the terminal prompt. Let us start it again. Type IPython3 in the terminal and press enter. Now let us learn how to use the interpreter. Let us start with the simplest operation, addition. Type 1 plus 2 at the IPython prompt and press enter. We press enter to execute the Python command. Please do so after typing every command. IPython promptly displays the output as 3. Notice that the output is shown with an out square brackets 1 indication. Let us now try a few more operations such as 5 minus 3, 7 multiplied by 4. Each time we press enter and see the output on the IPython console window. Let us see how we can navigate to previous commands in IPython. For example, say we want to execute print open parenthesis 1 plus 2 close parenthesis. Instead of typing the whole command, we can recall the command 1 plus 2 we typed earlier. Use the up arrow key to go back to the command 1 plus 2. Now use the left arrow key to navigate to the beginning of the line. Type the word print, open parenthesis, close parenthesis on the keyboard. We have changed the command to print 1 plus 2. Now press enter. The interpreter prints the result as 3. Notice that this time the indication out square brackets is not displayed. Now let us execute print 10 multiplied by 2. We use the up arrow key to navigate to the previous command print 1 plus 2. Now replace 1 plus 2 with 10 multiplied by 2 and press enter. As with any programming language, asterisk is used for multiplication operator. Observe the output on the console. Now let us see what is tab completion. Let us consider an example. Supposing we want to use the function print. For this, we just type pri at the prompt and press the tab key. As you can see on the console, that IPython has auto-completed the command pri to print. This feature of IPython is called tab completion. Let us see some more possibilities of tab completion. Just type p and then press the tab. In this case, we see that IPython does not complete the command. This is because there are more than one commands beginning with p. Therefore, it just lists out all the possible tab completions of p. Now let us try an exercise. Pause the video, solve the problem and resume the video. Find out the commands starting with AB. List out the commands starting with A. AB auto-completes to ABS tabs. A tab displays a list of all the commands starting with A. Now let us see what the function ABS is used for. We will use the help feature of IPython to find out this. To see the documentation of a function, type the function name followed by a question mark. The IPython interpreter will show the documentation for the function. On the displayed information, it says abs accepts a number as input and returns its absolute value. Let us see a few examples. On the console, type ABS minus 19 and then ABS 19. We get 19 as expected in both the cases. Now let us try it for decimal numbers. Let us try ABS minus 10.5. We get 10.5 as the result. Look up the documentation of round and see how to use it. Switch to the console for the solution. You can look up the documentation of the function round by typing round question mark. It says here that the function round rounds a number to a given precision. N digits is the precision value for round function. Notice there are extra square brackets around n digits. This means that n digits is optional and 0 is the default value. Optional parameters are shown in square brackets in Python documentation. Check the output of round 2.48, round 2.48, 1, round 2.484, round 2.484, 2. We get round 2.48 is equal to 2.0, round 2.48, 1 is 2.5, round 2.484 is 2.0, round 2.484, 2 is 2.48, which are what we expect. Let us now see how to correct typing errors, which we could make while typing on the console. Let us make a typing error deliberately. Type round, open parenthesis, 2.484, and press enter without closing the parenthesis. We get a prompt with dots. This prompt is the continuation prompt of IPython. It appears when the previous line is incomplete. Now complete the command with close parenthesis and press enter. We get the expected output, that is true. What if we type an incorrect command and end up with the continuation prompt? In such a case, we can press Ctrl-C keys to interrupt the command and get back to the IPython prompt. Round takes only numbers as input. Type round 1A. Do not close the parenthesis and press enter. We gave alphanumeric value 1A as input. Press Ctrl-C to interrupt the execution. Type round 2.484 without closing the parenthesis and press enter. Then cancel the command using Ctrl-C. Type the command round 2.484, 2. The output on your console should look like this. This brings us to the end of this tutorial. In this tutorial, we have learned to invoke the IPython interpreter by typing IPython in the terminal, quit the IPython interpreter by using Ctrl-D, navigate the IPython session history by using the arrow keys, use tab completion to work faster, see the documentation of functions using question mark, interrupt commands using Ctrl-C when we make an error.
Hello friends, welcome to the tutorial on using plot command interactively in IPython. Now type IPython3 and press enter. Let us initialize the Pylab package. Type %pylab. and press enter. Let us first understand what is Spylab. Spylab is a convenient Python module which provides plotting functionality and has mathematical and scientific functions. After running %pylab in the IPython console, you will see a message using matplotlib backend. This means matplotlib is running. But sometimes you may get an error that says import error, no module named matplotlib. In such cases, you have to install matplotlib and run this command again. Let us come back to the IPython console. Type linspace followed by a question mark in IPython console. Press enter. Please note that the command is linspace and not linspace. The displayed information says that linspace return evenly spaced numbers, which are calculated over the interval start and stop. Press Q to exit the documentation and return to the console. Let's try to generate 100 points from 1 to 100. Type linspace brackets 1, 100, 100. Here 1 is the start, 100 is the stop, and the next 100 is the number of points. Now press enter. As you can see, a sequence of numbers from 1 to 100 is displayed. Now let's try to generate 200 points between 0 and 1. We do that by typing linspace brackets 0, 1, 200 and press enter. Here is the expected sequence of numbers. In linspace, the start and stop points can be integers, decimals or constants. Let us now learn about the len function. First, we will generate 100 points between -pi and pi. So type linspace brackets -pi, pi, 100 and press enter. Here, pi is a constant defined by pylab. Now let us save this to a variable say p. Press enter. If we now type len bracket t and press enter, we will get the number of points between -pi and pi. Len function gives the number of elements present in a given sequence. Next, let's try and plot a cosine curve between -pi and pi. For this, we use the plot command. Type plot brackets t, cos t and press enter. As you can see from the cosine plot, cos t get the cosine value at every point corresponding to p. We can also assign the value of cos t to a variable cosine by typing cosine is equal to cos t. Press enter. And then plot by typing plot t, cosine and press enter. To clear the plot, we have to use the CLF function. This avoids overlapping of new plots over older plots. In the console, type CLF and press enter. The previous plot is cleared and a blank plot window is displayed. Now let's try to plot a sine plot. Type plot brackets t, sine t and press enter. A sine plot is displayed. To study the plot better on the plot window, we can use various options that are available on it. Let us have a look at these options. Moving the mouse pointer along the plot gives us the location of each point on the plot. Notice here, at the bottom left of the window, there are few buttons. The rightmost among them is for saving the file. Just click on it and type the file name. Let us save the plot by the name sine_curve in PDF format. Click on the drop-down here. As you can see, there are many formats in which to save the file. Formats like PNG, EPS, PDF, and PS are available. We have to specify the format that we prefer at the time of saving. To the left of the save button is the slider button. Using this button, we can specify the margins of the plot window. To the left of the slider button is the zoom button. It is used to zoom into the plot. Just specify the region to zoom into. The button to the left of zoom can be used to move the axis of the plot. The next two buttons with left and right arrow icons change the state of the plot. It takes us to the previous or next state of the plot. It acts like the back and forward button in a browser. The last one is home, referring to the initial plot. This brings us to the end of this tutorial. In this tutorial, we have learned to start IPython with pylab, use the linspace function to create equally spaced points in a region, find the length of sequences using len function, plot mathematical functions using plot, clear drawing area using CLF, usage of buttons in the UI of the plot window such as save, zoom, move axis, back and forward, home. Hello friends, welcome to the tutorial on embellishing a plot. Type IPython 3 and press enter. Let us initialize the pylab package. Type %pylab and press enter. We shall first make a simple plot and start modifying it. Type x is equal to linspace inside the brackets -2, 4, 20 and press enter. Then type plot inside the brackets x, sin x and press enter. We can now see the sine curve in the plot window. The default color and thickness of the line is as decided by pylab. Let us now change the parameters of this curve. We can pass additional arguments to the plot command to do this. We shall first clear the plot window by typing CLF in the IPython console. You can now see a blank plot window. Now plot the same sine curve with an additional color argument. So we will type plot inside the brackets x, sin x, inside inverted commas r and press enter. Here the argument r is for red color. On the plot window, the same sine curve is now seen in red color. Do not close the plot window, just minimize it. We can alter the thickness of the line by using the line width argument. This time, we will draw the cosine curve on the plot window. So type plot inside brackets x, cos x, line width is equal to 2. Press enter. A cosine curve with line thickness 2 is produced in the plot window. Let us now try to plot a sine curve in blue color with line width as 3. Here onwards, press the enter key to execute every command that we type on the IPython console. Let us first clear the plot window by typing clf. You will again see a blank plot window. Now type plot inside the brackets x, sin x, inside inverted commas b, line width is equal to 3. A combination of color and line width would do the job for us. To get the plot in dotted style, instead of a solid style, put a dot in line style. First, type clf to clear the plot window. Now type plot inside the brackets x, sin x, inside inverted commas dot. We get the sine curve in dotted style. Let's see the information of plot. Type plot ? And press enter. Plot the curve of x versus cos x in red dash line and line width 3. Let us switch to the console for the solution. Type clf to clear the plot window. Now type plot inside the brackets x, cos x, inside inverted commas r, hyphen, line width is equal to 3. We use a combination of line width argument and line style. Now we know how to produce a bare minimum plot with color, style and thickness. Let us look at modifying the plot further. Let us start with a plot for the function minus x square plus 4x minus 5. Now type plot inside the brackets x, minus x multiplied by x plus 4 multiplied by x minus 5, inside inverted commas r, line width is equal to 2. We will see the curve of this equation in the plot window. But the figure does not have any description describing the plot. To add a title to the plot, use the title command. So type title inside the brackets, inside inverted commas, parabolic function minus x square plus 4x minus 5. The title command, as you can see, takes a string as an argument. We can see the title on the plot window. But it is not formatted and does not look clean. It would look even more shabby if there were fractions and complex functions. Let us write the title in LaTeX format for a neater look. For LaTeX format, we put a $sign before and after the string. Type title inside the brackets r, inside inverted commas, parabolic function minus x square plus 4x minus 5 $. Here, r means that the string is to be treated as a raw string. It will ignore all escape codes. As we can see that the polynomial in the title is now formatted. Although we have title, the plot is not complete without labeling the x and y axis. So we will label x and y axis in LaTeX style. Type x label inside the brackets r, inside inverted commas, $x, and y label inside brackets r, inside inverted commas, $y. The plot is now almost complete. Now we will name the points considering point 2, -1 as local maxima. To name a point, we use the function annotate. Type annotate inside the brackets, inside inverted commas, local maxima, xy is equal to, inside brackets, 2, -1. We can see the local maxima at point 2, -1. The first argument in annotate command is the name of the point. The second argument represents the coordinates of the point. It is a tuple containing two numbers. The first is x coordinate and second is y coordinate. Next, type xlim brackets. Xlim function returns the current x-axis limits. Then type ylim brackets. Ylim function returns the current y-axis limits. Set the limits of x-axis from -4 to 5 by typing xlim inside the brackets -4, 5. Similarly, set the limits of y-axis in a similar manner. Type ylim inside the brackets -15, 2. Make an annotation called root at the point -4, 0. What happens to the first annotation? Switch to the IPython console for the solution. Type annotate inside the brackets, inside inverted commas, root, xy is equal to -4, 0. Every annotate command makes a new annotation on the figure. This brings us to the end of this tutorial. In this tutorial, we have learned to modify the attributes of a plot like color, line width, line style by passing additional arguments. Add title to the plot using the title command. Incorporate LaTeX style formatting by adding a $sign before and after the string. Label x and y axis using x label and y label commands. Add annotations to a plot using annotate command. Get and set the limits of access using xlim and ylim commands.
Hello friends, welcome to the spoken tutorial on saving plots. Now type IPython 3 and press enter. Let us initialize the Pylab package. Type %pylab and press enter. Let us plot a sine curve from -3π to 3π. First, we will calculate the required points for the plot. To do this, type x is equal to linspace -3 star pi, 3 star pi, 100 in the console. Let us plot a sine curve for the point stored in variable x. Type plot x, sine of x in the console and press enter. Don't close the plot window for the rest of the tutorial. Here you can see that we have made a very basic sine plot. Now let us see how to save the plot. For saving the plot, we will use the savefig function. Savefig function takes one argument, which is the file name. Type savefig sine.png and press enter. This saves the file in the present working directory. The characters after the dot in the file name is the extension. It determines the format in which you want to save the file. To check the current working directory, type pwd in the console and press enter. To save the file in a different directory, type full path of the directory before the file name. Type savefig /home/fossee/sine.png. Note that the above file path is for Linux-based file system. For Windows, give the entire file path as shown here. Here, FOSSEE is the username in Windows, and sine.png file is to be saved on desktop. Here we have used an extension .png. This will ensure that the image is saved as a PNG file. Now let us locate the file sine.png, which we had saved earlier. We have saved the file to /home/fossee. Let us navigate to /home/fossee using the file browser. Open sine.png to see the plotted sine curve. Savefig can save the plot in many formats, such as PDF, portable document format, PS, PostScript, EPS, encapsulated PostScript to be used with LaTeX documents, SVG, scalable vector graphics, .png, portable network graphics. Save the sine plot in the EPS format. Let us see the output for this exercise. Type savefig /home/fossee/sine.eps and press enter. Now let us go to /home/fossee and see the new file created. We see the file sine.eps here. In this tutorial, we have learned to save plots using the savefig function, save the plots in different formats like PDF, PS, PNG, SVG, and EPS.
Hello friends, welcome to the spoken tutorial on multiple plots. Now type IPython3 and press enter. Let us initialize the Pylab package. Type %pylab and press enter. Let us create a set of points for our plot by using the command linspace. Type x is equal to linspace inside the brackets 0, 50, 10. Now let us draw a simple sine curve using these points. Type plot inside the brackets x, sin x. As we can see, this sine curve is not a smooth curve. What really caused this? This happened because we selected few points, that is 10 for this large interval of 0 to 50. Plot function does not plot the analytical function. It plots the points given by the analytical function. Now let us use linspace command to get 500 points between 0 and 50 and draw the sine curve again. Type y is equal to linspace inside the brackets 0, 50, 500. Plot inside the brackets y, sin y. Now we see a sine curve with a smooth curve. Notice we will also have two plots, one overlaid upon another. In Pylab, by default, all the plots are overlaid. To distinguish between two overlaid plots, we use the legend command. Type legend inside the brackets, square bracket, sin x, sin y. The legend command takes parameter as a list of strings. Then it assigns strings to plots in the order they were created. Now we can see the legends being displayed for the two sine curves on the plot area. In the IPython terminal, now type CLF to clear the plot window. Draw two plots. First plot being a parabola of the form y is equal to 4x squared, and the second being a straight line of the form y is equal to 2x plus 3 in the interval -5 to 5. Use legends to indicate what each plot is doing. Switch to the terminal for solution. Type x is equal to linspace inside the brackets -5, 5, 100. We can obtain the two plots in different colors using the following commands. Plot inside the brackets x, 4 multiplied by inside the brackets x multiplied by x. Plot inside the brackets x, 2 multiplied by x plus 3. Now we will add a legend to identify the plots. Type legend inside the brackets, inside square brackets, r inside inverted commas, $y is equal to 4x squared, r inside inverted commas, $y is equal to 2x plus 3, We can see the legend added to the plot. Next, we will learn to switch between the plots and perform operations such as saving the plots, etc. Let us see how to accomplish this. But before we move on, let us clear our screen. Type CLF. Type x is equal to linspace inside the brackets 0, 50, 500. To accomplish more control over individual plots, we use the figure command. Type figure 1. Plot inside the brackets x, sin x, inside inverted commas d. Figure 2. Plot inside the brackets x, cos x, inside inverted commas g. Now we have two plots, a sine curve and a cosine curve in two different figures. The figure command takes an integer as an argument. This is the serial number of the plot to select corresponding plot. All the plot commands we run hereafter are applied to the selected plot. In this example, figure 1 is the sine plot and figure 2 is the cosine plot. For example, we can save each plot separately. Type title inside the brackets, inside inverted commas, cos x. Save inside the brackets, inside inverted commas, cosine.png. Figure 1. Title inside the brackets, inside inverted commas, sin x. Save inside the brackets, inside inverted commas, sine.png. The figures will be saved in current working directory. Now, close both the plot windows. Draw a line of the form y is equal to x as one figure and another line of the form y is equal to 2x plus 3. Save each of them. Switch to the terminal for solution. To solve this problem, we will use the figure command to create first plotting area. Type figure 1. X is equal to linspace inside the brackets -5, 5, 100. Plot inside the brackets x, x. Now, use the figure command to create second plotting area and plot the figure. Type figure 2. Plot inside the brackets x comma 2x plus 3. We will save the figure as follows. Type figure 1, save fit inside the brackets inside inverted commas, plot1.png. Figure 2, save fit inside the brackets inside inverted commas, plot2.png. This brings us to the end of this tutorial. In this tutorial, we have learned to draw multiple plots which are overlaid, use the figure command, use the legend command, switch between the plots, and perform some operations on each of them, like saving the plots. Hello friends, welcome to the spoken tutorial on subplots. Now type IPython 3 and press enter. Let us initialize the Pylab package, type %pylab and press enter. To compare two plots, we draw the plots in the same plotting area. Let us now create two plots, a cosine plot and an exponential curve in the same plotting area. Type x is equal to linspace inside brackets 0, 50, 500 and press enter. Plot inside the brackets x, cos x. Type y is equal to linspace inside brackets 0, 5, 100. Plot inside brackets y, y square. Here, the two plots have different regular axes, so we cannot draw overlaid plots. In such cases, we can draw subplots. We use subplot command to accomplish this. Type clf subplot inside brackets 2, 1, 1. We can see the first subplot. The subplot command takes three arguments. The first argument is the number of rows of subplots that must be created. Here, the first argument is 2 to split the plot horizontally. The second argument is the number of columns of subplots that must be created. Here, the second argument is 1, so plot will not split vertically. The last argument specifies the serial number for the subplot. Here, we passed 1 as the argument, which creates the upper subplot. If we execute the subplot command as subplot inside the brackets 2, 1, 2, the lower subplot is created. Here, we can see now two subplots. Now, we can draw plots in each of the subplot area using the plot command. Type subplot inside brackets 2, 1, 1, plot inside brackets x, cos x. Now, type subplot inside brackets 2, 1, 2, plot y, y square. This created two plots, one in each of the subplot area. The top subplot holds a cosine curve and the bottom subplot holds a parabola. It is clear from the two subplots that both have different regular axes. For the cosine curve, x-axis varies from 0 to 15 and y-axis varies from -1 to 1. For the parabolic curve, x-axis varies from 0 to 5 and y-axis varies from 0 to 25. Now clear the plot window. Pressure, volume and temperatures are held by the equation PV is equal to nRT, where nR is a constant. Assume nR is equal to 0.01 joules per Kelvin and T is equal to 200 Kelvin. V can be in the range from 21 cc to 100 cc. Draw two different plots as subplots, pressure versus volume plot and pressure versus temperature plot. Switch to the terminal for the solution. To start with, we have been given the range of volume from which we can define the variable V. V is equal to linspace inside brackets 21, 100, 500. We can create first subplot and draw pressure versus volume graph using this V. Subplot 2, 1, 1. Plot V, 2.0 by V. We know that nRT is a constant which is equal to 2, since nR is equal to 0.01 joules per Kelvin and T is equal to 200 Kelvin. Now we can create the second subplot and draw pressure versus temperature plot as follows. Subplot 2, 1, 2. Plot 200, 2.0 divided by V. We have an error now, telling x and y dimensions don't match, so we will create same number of points for temperature. Type T is equal to linspace inside brackets 200, 200, 500. Now we have 500 values in T and each with value 200 Kelvin. Plotting this data, we get the required plot. Plot inside brackets T, 2.0 divided by V. We can see two subplots of pressure versus volume and pressure versus temperature respectively. This brings us to the end of this tutorial. In this tutorial, we have learned to create subplots and to switch between them.